If you're writing Python code, you need to be using virtual environments. Let's talk about why. Welcome to this quick hits video. My name is Kevin Fiesel, and I'm the proprietor of Catalaxy Services LLC, a consulting firm which specializes in work all across the data platform space, especially SQL Server. I have had a few playlists in which I've made use of Python code. In pretty much all of them, I make use of a concept known as a virtual environment, and today I'm going to explain why. First, let's talk about the concept of virtual environments. A virtual environment is an independent set of Python packages in its own site directory. We start with a base Python installation, and from there, we build a separate directory of the Python binaries and packages that we need for a particular project. The definition makes mention that you may optionally isolate packages from the base environment, and I strongly recommend you do so. Here is why. Let's say you install some distribution of Python. This could be the version of Python in the Windows Store or from your Ubuntu apt repository. It could be the Anaconda distribution of Python, Miniconda, or whatever. You have your installation of Python and all is well. Then you install some packages because you want to try out the newest variant of Claude or write some code to visualize your data. You will, of course, need to install some more packages. All of that is fine until you need to do something else. Then you'll have to get a new set of packages, which is okay until you end up hitting one of the most common Python packaging issues. For one project, you need package blah 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 version 2.4 or earlier. But for another project, you need version 2.5 of blah blah blah, and you can't have both package versions installed at the same time. This is a very common mess we can find ourselves in, and it's kind of tough to extricate ourselves from it. If you're old and crotchety like I am, you probably remember the days in Windows where different versions of the same DLL could not coexist, and so installing one program could cause another program to crash because the DLL version changed. Well, Python has recreated that joy for all of us yet again. But fortunately, there is a way to extricate ourselves from the mess: virtual environments. Join me in this demo and we'll see just how they work. Here we are in the Windows terminal, specifically a Windows command prompt. I'm in a temp directory on the C drive. If I run dir here, I can see a simple requirements.txt file. If I run the command more on this requirements file, we can see that I want a few packages like Streamlit, Pandas, and NumPy. Next, let's run pip freeze. This will tell me all of the packages I've installed via pip, which on this pretty fresh installation of Windows is 0. I have none of the packages. I could easily install these packages using the following command. But I'm not going to run this because that will install in my base Python installation, and the next thing that I want to run that requires Python may have conflicting requirements. Instead, let's create a virtual environment. To do so, in the command prompt, I'm going to run the following command. This will create a new virtual environment and name it code_test. If I run a directory listing now, I can see a new folder called code_test. Let's navigate inside of there. In here, I see a .gitignore file. Let's run more on that to see what's in it. We can see that this tells Git to ignore anything in this directory or a child directory. The reason is we don't want to check virtual environment contents into source control. We can easily recreate a virtual environment on a separate machine, and these things can get pretty large, hundreds of megabytes or even more than a gigabyte, depending on how many packages you're installing and all of those packages' dependencies. If I jump into the scripts folder and run dir here, we're going to see a few things. I see 4 separate activation scripts. The first one, without an extension, is for Linux or macOS. The second is a batch file, which is what we'll run in the command line. The third is a .fish extension, which is for the fish shell. Now, that's not a shell program I've used before, so I'm not sure how popular it is, but it is at least popular enough to show up here. Finally, we have a PowerShell script. Next, we have a deactivation batch script. That's one way to leave the confines of our virtual environment. I can see various copies of pip, which let me install packages. I see python.exe, which runs Python in a command line, and I see pythonw.exe, which lets me run programs in a GUI. In short, this directory contains the bare minimum I need to run Python. I also think it's instructive to check out one of these activate scripts. They're pretty similar all in all, save that the PowerShell version is significantly lengthier and includes a lot of documentation. Let's take a peek at the shortest of these, activate.bat. We can see early on that it sets an environment variable called virtual_env to our code test directory. It adds in the phrase code_test in parentheses to the beginning of our prompt so that we can see that we are in the code test virtual environment. It then includes the scripts folder as the first entry in our path. So if we run the command Python, it will first look in the code_test \scripts directory before looking anywhere else. There are a few other things this script does, but we've covered the most important bits. Let's jump back up 2 directories to the code directory. One last thing, I'll use the command where Python to figure out where my default Python installation is. Running this command, I can see that I have it in appdata \local as I've installed it via the Windows Store. Now, I'll activate the virtual environment. For a command prompt, I need to run activate.bat. Just as the script foretold, our prompt now has code_test in parentheses. That's how we can tell we are in a virtual environment. Next, I'll run where Python again. This time, we can see 2 variants of Python show up, and the first one is in the code_test folder. Thus, when I run the command Python, it will kick off the version in my code_test folder instead of the default version I got from the Windows Store. Before I do that, however, let's run a pip freeze. Doing so will take just a moment, and we'll see that, again, I have 0 packages. Let's fix that by running the pip install command. Doing so will contact PyPI servers, and eventually I'll start downloading a variety of packages. There's quite a bit that installs as part of this, so I won't bother making you sit here and wait for it to install. Instead, let's jump ahead in the story a bit, shall we? Great, we now have a variety of packages available to us in the virtual environment, and I can tell this by running the pip freeze command one more time. Now, let's quickly deactivate this virtual environment. I can do so using the deactivate command. We can see that our prompt returns back to normal, and if I run pip freeze again, we have nothing. That's exactly what I want to see, as it implies that all of our installation happened within the virtual environment, not within our base Python installation. To prove this, I know that I installed Streamlit, a library that helps us build data applications in Python. And by the way, if you're interested in Streamlit, I have an entire video series on it. I'll link it in the description below. If I run the Streamlit command here, I get an error that Streamlit is not a valid command. Let's return back to the virtual environment by running my batch file in the code_test \scripts directory. Now, if I run Streamlit, I get some command line options, proving that I can access it. And if I ask where Streamlit, we can see that it's in the scripts folder. That was the command prompt, but I want to prove quickly that this isn't just for the Windows command prompt. Let's switch to a PowerShell terminal. I'll make sure that I'm in the c:\temp\code directory. Then I want to run the activation PowerShell script. Before I do that, I'll run pip freeze, just to prove that we are in the base environment. Let's run this script, and we can see that the prompt shows our virtual environment. It even colorizes it for us, so that's pretty neat. And I can prove that we're in the virtual environment by running the Streamlit command. We can now see Streamlit's demo output. And just to see how it works in Linux, I have a Windows subsystem for Linux setup running in an Ubuntu container. I first need to get to the correct directory. If I want to know where my Python command is, instead of using the where command like we did in the Windows command prompt, it's which in Linux. Running this, we don't see any results. The reason for this is Python on Linux is actually called Python 3. Sometimes we create symbolic links so people can simply run the command Python, but that's not something that happens by default on an Ubuntu installation with the Python package installed. Instead, let's switch this to ask which Python 3 we have. Now we can see that Python 3 is in /user/bin. If I run a pip freeze command, I can see that I don't even have pip installed. So let's create a new virtual environment. The one that I have is really intended for Windows installations, and the operations are a little bit different on Linux. If I try to run this command, I get an error message that I don't have the Python 3.12-venv package. So let's install that. This is going to install a few things along the way, and we'll be able to try creating a virtual environment again. Creating this virtual environment will take a moment, but when it's done, I can cd into the code_Linux directory. Now, if I run an ls command, it will list the directory contents. In our Windows virtual environment, we had a few folders like include and scripts. For this one, we have bin, include, lib, and lib64, or lib and lib64. We also don't have a .gitignore, so we can see that the code to generate a virtual environment is a bit different between these two operating systems. Let's jump back to the code directory and I'll show you how to activate a virtual environment in Linux. The source command says that I want to execute a script. The script that I want to execute is the activate script, which is in the bin directory. If I do this, I'm now in the code_Linux virtual environment. I can tell this by running which python3, which shows me that my Python executable is in the bin directory. I can also ask which pip3 and see pip is available, even though it is not available for the base installation of Python because I have not installed that Ubuntu package. If I run a pip freeze command, we have no results. So let's install all of our requirements here as well. Just as before, this is going to take a little while, so let's speed ahead to the point where this is ready to go. And now we're done. Just like before, I can run Streamlit and we'll see that it does work. When I'm done with everything, I can run the deactivate command and leave the context of this virtual environment. Now, let's say that I completely goofed up my virtual environment. Maybe I installed some stuff I didn't intend to, or I'm stuck in some dependency purgatory. The good news is that the virtual environments are ephemeral and they're independent of our code. First, I can delete the old virtual environment. This will get rid of all of the existing package installations and that kind of stuff. And in Windows, I can just navigate to the directory in the Windows Explorer app and delete the folder. Then I can create a brand new virtual environment and start installing packages again. I don't lose any work. Also, I can have many virtual environments on a single machine. I might have one virtual environment per project. I could then put them in the project directory and source code, or even in some virtual environments directory so that I could centralize them. And because activating a virtual environment is just a script, whether that's a bash script, a batch file, or a PowerShell script, I can include virtual environment activation in my own scheduled tasks, and it'll work just fine. And that's going to do it for this explanation of virtual environments. I know it's a bit of a strange experience for people coming from Java or .NET backgrounds, but if you make regular use of virtual environments in Python, you'll run into fewer problems down the line, as well as make your own code easier to manage, especially in a busy environment. But before I wrap things up, I do want to answer one question around virtual environments. Do we need virtual environments if we are using Docker containers? The answer is no, but maybe yes. In general, when we containerize a Python application, we are isolating that installation of Python, and we won't have anything else running in that container. To that end, we don't need to worry about package version incompatibilities or any of the other issues we might hit, and that obviates the need for virtual environments. But there are exceptional cases, and they often revolve around more complicated tools. For example, I have found that running a Streamlit application from a container can work, but it's a little tricky figuring out where Streamlit gets installed within any given container. But if you use a virtual environment, you will know exactly where the Streamlit binary is, and activating that virtual environment will make Streamlit immediately accessible. I'm sure that there are other packages that behave similarly, but Streamlit is the first one that comes to mind because I have experienced this issue. We'll have links and show notes in the description below, and until we see each other in the next video, take care.